Hello friends. Now after previous discussion, we are going to start with basic concepts of geomorphology. As we know, it is the first topic of the geography syllabus and has many subtopics. We consider it as the most time-taking topic. It's the bulkiest topic and has many concepts from geology as well as the geography aspect. So, if you see the formation of development of geomorphology, it was earlier physiography, which means the physical detailing of Earth. And with the advent of science and technology and with the advent of new explanation, the geological principles were used to explain the formations on the surface of Earth. And the concept is called as geomorphology. If we understand the meaning of geomorphology, the literal meaning of geomorphology is morphos, that means form of Earth. So what is meant by this form of Earth and how do we study this is that it is a description of whatever we see on the surface of Earth, that is landforms like plateaus, plains, volcanoes, fold mountains, rift valleys, landforms, and the formation of landforms, the process involved in the formation of landforms is included in geomorphology. So if you see the scope of geomorphology, the scope of geomorphology is based on understanding the development of landform. And there were different school of thoughts which we'll be discussing little later, different school of thoughts in geomorphology, where American school of thoughts stands out. So geomorphology, if you see a landform, the development of landform, it is based on three processes which were explained by Davis, also called as Davisian trio: structure, process, and stage. Structure, process, and stage. The structure refers to the lithology of the landform. Lithology of the landform, that is the composition of landform. The composition of landform actually determines how landform develops and what are the different processes that can be applicable on the landform, such as if you see the sedimentary rocks, the erosion in sedimentary rocks, it is much faster in comparison to the metamorphic rocks, in which the erosion is slower, it's gradual. So the development of landform in case of sedimentary rocks will be much faster than in the case of metamorphic rocks. So that is how one idea, how structure will play an important role. And also we know that if you see the rate of erosion, it is also dependent upon how quickly the particles are removed. You see, sand particles are removed much faster than pebbles or boulders. If the surface has many fault lines, water percolates into deeper layers and causes erosion. So, structure therefore plays one of the most dominant role in determining the evolution of landform, which was explicitly mentioned by W.M. Davis in his concept of landform development. Then second point that is very important is the process. Process means how does this landform evolve? What are the different erosive agents that are acting on the landform? So, if it is water, we call it as fluvial process. And if you observe fluvial process, see the river forms a different types of landforms than glaciers. We have V-shaped valleys, U-shaped valleys, and some boulders and plains when it comes to the process of erosion in fluvial. Then second process that is very, very important is glacial process. Now the type of erosion here in case of fluvial is different than the type of erosion that happens in the glacial. I'll just take one example. Suppose in case of river erosion, the river causes maximum erosion at the valley base. It also causes erosion at the wash slopes or along the slopes of the mountains, but maximum erosion at the valley base when it is in the youthful stage. But if you see the movement of glacier gets attached to the surface because it is adhesive, ice is adhesive in nature, and removes this upper particle, removes this upper layer and makes the mountain look even steeper. Now here it is the erosion called as vertical erosion or hydraulic action. Hydraulic action means caused due to the mechanical impact of water, and here it is plucking. The process of plucking, that means the removal of particles when ice gets attached to a weaker surfaces, weaker particles, and gets removed from there. And that is how the process, the glacial process differs than the fluvial process. Again, and therefore plays a significant role in the landform development. Same thing, wind erosion. We call it as aeolian process. Now suppose we have these features, a landform in the desert region, and because wind is a main agent of erosion here due to lack of water and glacier. Now you can see we generally have flat topped mountains which have different names called as mesas and buttes and other. We also know, we can easily understand that wind has more erosion in the middle part and lesser on the upper part and lower part, because in lower part velocity is less, in upper layer of the wind the erosive particles are less. So the middle part of wind has faster rate of erosion. Therefore these mushroom rock kind of formations we find in wind erosion. So this is how three different processes, fluvial, glacier, wind, giving rise to three different types of landforms. So landforms being a agent of landforms being dependent upon the process. Then the third is stage. Stage means time. A young fold mountain having a steeper slope erodes at a much faster rate than the mature stage. The landform that is found in youthful stage, because it is young fold mountain and has a higher river has higher energy, you find more erosive landforms. But as the landform matures, as time passes, after millions of years, the landform that we find is more depositional landforms. So this is how landform is dependent upon three components or three important aspects, that is structure, process and stage. Most of the geomorphologists have focused on stage. Most of them have focused on youthful stage, mature stage, old stage, being a major or the most dominant determinant of landform evolution, which we will be discussing in the cycle of erosion and the concept of landforms. So that is how we focus on landform, how we study landforms. Then if you see the development of geomorphology, if you throw a light on the history of geomorphology as a concept or as a subject altogether, we find that it has been a part of, rather one of the oldest subject of geography that we have been studying. But the development of modern geomorphology starts with some new concepts, such as a concept given by James Hutton, which was called as uniformitism. A philosophy by James Hutton. What is uniformitism and how do we actually understand the uniformitism as? See, in the present age, we see Himalayas getting eroded because rivers are flowing at a faster rate and the height of the Himalaya reducing. In the past, it must have also happened with Aravalis. It must have happened with the old mountains like, old fold mountains like Ural mountains. Therefore, the height has reduced. So in future, height of Himalayas will also reduce. So that means the processes which are going now must have occurred in the past as well. So there is a uniformitism prevailing. This particular concept or idea of uniformitism actually formed the basis for cyclicity, that is time dependent evolution of landforms. Time dependent processes which are sequential, repetitive. So the concept is of cycle of erosion. So uniformitism mentioned by James Hutton laid the foundations for most of the geomorphic phenomena, and he says all those processes which are occurring now must have occurred in the past. Later Thornbury added that, maybe with a varying degree of intensity, but all the processes, if today river causes erosion, in the past it must have caused erosion, and if with the erosion, if the landform, height of the landform reduces, it must have occurred in the past as well. It will occur in the future as well. So if you have to understand the past, present is the key to past. So with this statement, we have new development of geomorphology. The center of geomorphology, or you can say the most dominant school of thoughts in geomorphology, becomes the American school of thoughts. We just briefly discussed that. I also understand when we are starting geomorphology and we have little idea about what is geomorphology and we have not discussed many processes, it's a bit difficult to connect with all that, but we must understand how a topic has evolved. Then we can easily relate to many concepts. One of the most dominant school of thought was this that developed in North America, which was called as American School of Thoughts. Now, the biggest name, of course, is W.M. Davis, who organized the School of Thoughts in 1904. But the first name in American School of Thoughts is by J.W. Powell. For some reasons, American School of Geomorphology was mainly focused on erosional activities. They paid less attention to what is happening under the surface of Earth, or they paid less attention to the endogenetic forces. They emphasized more and more on what is happening on the surface of Earth, exogenetic forces. So they considered exogenetic forces as dominant forces as well, and gave a concept of erosion. But you understand what is meant by erosion? We say removal of upper layer of weaker particles and all that. But then the question comes, up to what level erosion will take place? Up to which height the erosion is going to take place? So Powell made it very interesting comment on this and gave a concept of base level, which is also referred as sometimes grand base level or the sea level. Now we define base level as the last limit up to which river can cause erosion. The last limit up to which river will flow, and the base level erosion will, the erosion will stop at that level. So that came to be known as base level, the concept of base level. That means a river is flowing to achieve the base level, and therefore if the river is flowing, the erosion will take place. Later, some different types of base levels were mentioned, which was called as local base level, called as grand base level, which we'll be discussing in our topics later. So when he established this base level, the focus goes on the erosion and the last limit up to which erosions can take place. After J.W. Powell, the real geomorphologist before W.M. Davis was G.K. Gilbert. Now G.K. Gilbert, he made a very significant contribution. He is called as real geomorphologist of North America and made a very elaborate explanation on subaerial erosion. He elaborated subaerial erosion, gave the concepts of lateral erosion in the valleys, vertical erosion in mountain valleys, gave a concept of law of streams. If you see, all of us know erosion takes place, the upper particles are removed and there's a deposition and all that. But now he focused on laws of stream. Some of the laws, like in the youthful stage, we know the river velocity is very, very high. And a velocity is high because of its speed, because of its velocity is high because of slope. And this higher potential energy because of the height gets converted into higher kinetic energy. So, because the velocity is high, the carrying capacity of the river is also high. Now he introduces the concept of carrying capacity, which means the maximum amount of traction load that a river can carry along with it, and stated some laws like carrying capacity being proportional to 6th power of velocity. Then some other concepts such as the carrying capacity reduces, deposition rate increases. So wide study that he made on denudation and subaerial erosion, G.K. Gilbert. And after these two, now the name is W.M. Davis. Now, he was one of the strong, geomorphologists of his times, and also organized this American school of thoughts in 1904. And in this American school of thoughts, what did he do actually was focus on geomorphological phenomena, subaerial erosion, organized the laws of G.K. Gilbert, used them, and propounded his concepts of cyclicity. Focused on cyclic development of landform, that a landform passes from youthful stage to mature stage to old stage. He was very impressed with Darwinian principles and uses that same concept of evolution of landforms as the evolution of living organisms. So as Darwin says that external factors will trigger a change in living organisms. Similarly, external factors will trigger a change in landform development. And therefore, landform were compared to the living organisms, youthful stage, mature stage, and old stage. Now, this is how the subaerial erosion becomes a very big topic was rather established as a major concept by the American school of thoughts. Parallel to this was European terms. Little different than what Americans focused. In Europe, in European school, Germany, if I say one of the biggest name is Penck, who focused on the cyclicity but in a different form, not as what W.M. Davis had said, and he was a critique of W.M. Davis. Russian geomorphologist Lomonosov, he's a Russian geomorphologist from Russia, was the first person to say that landform is an outcome of interaction of endogenetic forces and exogenetic forces. Till now, we were focusing only on the exogenetic forces, or American school of thoughts is mainly about the external forces, external factors, exogenetic forces such as erosion, and that too fluvial erosion was more focused. Now Lomonosov says that landform is a complex interaction of endogenetic as well as exogenetic forces. Endogenetic forces acting deep inside the surface of Earth. Deep inside the surface of Earth. Exogenetic forces acting outside the surface of Earth. Right, we often miss this, that Lomonosov was the first person who had given the concept of the endogenetic and exogenetic forces acting on landform. Later, Penck elaborated this concept in his idea of landform development and criticized W.M. Davis, an American school of thoughts, therefore, that it is not the exogenetic forces which are dominant, rather endogenetic forces are dominant. So he carried what Lemonceau said, he carried forward and presented his theory of landform development as the interaction, complex interaction of endo and exogenic forces. When endogenetic forces get weaker, exogenetic forces take over, and therefore the landform keeps on reducing. The height of the landform reduces. So now, this is how over the years geomorphology and geomorphological terms have taken shape, and the landforms have come. The concepts have been explained by various geographers. So this is how we have to study. First focus would be on the conceptual clarities, and also we will link almost every topic with the geographical thoughts, which is the biggest problem of in my previous discussion also I said that because people do not come from the geography background, we do not pay much attention towards geographical thoughts. Actually, the evolution of concept is also very important to understand. There have been questions in the past. In 2016, the question was asked, the contributions of American school of thoughts in subaerial erosion. Very few people were able to actually answer this because we do not actually relate to this school of thoughts and other things. We just focus on the topic and its concept and how to write answer on that. We must also understand the conceptual development and what have been the thought processes that were going on in different frames and different school of thoughts for almost every topic, including other topics of geography. Anyhow, so that is how we will be discussing in classes. Before we start further classes, we should be very clear about some concepts of geomorphology, that is geological time scale, because here when we say present is key to past, so we must also understand what happened in the past. We must also understand when we say stage or time, we must understand time, what has happened in the earth. There is a topic called as denudation chronology. There are topics in cycle of erosion where we continuously refer to the geological history of earth, what has happened in the past and what are the different processes and that have taken place. So today I will be discussing this geological time scale and helping you out to understand and remember this geological time scale. There will be an elaborate discussion of geological time scale after that. But first, how do we classify them and what are the ways to remember all this geological time scale? I see students a bit troubled with this time scale. Now, see, what is geological time scale? If you deeply analyze, there are two aspects in geography. One is space, another is time. We give names to the space, like we have names of India. For India, we have names for Russia, North America, cities, villages, etc. So we are giving a name to space. Similarly, to understand time and give a boundary of time, we give names to that time. And how do we give the names to time? It is given on the basis of the most distinct feature of that time. Like in history, we refer to a particular time frame as Indus Valley civilization. We refer a particular time frame as Vedic ages. Because during this time frame, a civilization developed and we can take a reference of that time by naming this civilization. So as space is given name, time is also given name. So geological past of earth has also been given names, which is basically called as geological time scale. These names are mostly on the basis of rocks that were developed at that particular time. So when we use the term Cambrian, it means that Cambrian era, what happened in the past on the surface of Earth. Now the word Cambrian comes from the Cambrian rocks of UK. Around 500 million years back, these rocks developed. Around 500 million years back, the Cambrian rocks developed. So we refer that name as a Cambrian rock. Similarly, we have other names like Ordovician, like Silurian, like Devonian, and so on. And time is always divided in different slots. A bigger time frame here is called as era. A smaller time frame called as period. Smaller time frame called as epoch. We also have a bigger time frame than era. It is called as eon. And the names of eras are based on life. Therefore, you will find the suffix used here is zoic, Paleozoic, Mesozoic, Cenozoic, and so on. So, how eras are named? First we will discuss that, and then periods, how to remember these periods, and epochs if at all they are there. See, if you go in the detail of history or say Indian history, because we do not have much details of Indus Valley, so we give this 1000 or 1500 years time frame just one name. That is say Indus Valley, or 1000 time frame, 1000 time slot as one name like Vedic name, Vedic age or later Vedic age. But when we come to the later part of the history or latest part of the history, you will find that the time has been divided in smaller slots because we have ample records to do so. Same when we see the past of Earth, which is around 4600 million years old, we do not have a lot of records left of this era. We don't have much of records left of say 3000 million years back. So because of the scarcity of records, geological or say biological records, fossil records, we have a limitation of naming the larger time frame as one. So let us start with this eras now. Oldest part, Azoic era. A means no life, around 446 million years back, Azoic era. And if I give you idea about the life here, life existed nowhere, so no life, the word Azoic. Somewhere around this later part, we have a term called as Archaeozoic. Archaeozoic. Somewhere around 2500 million years to around 4600 million years. Almost again very little life, but we had the origin of sea here. Less remnants of life in this time frame. Then later, we also have a different time here. We call it as Proterozoic era. Biologists have given the same Proterozoic era. Here we have life, and the life of invertebrates. Single cellular organism must have originated somewhere here. Then vertebrates must have developed in this era. So now you see the life is becoming a little more complicated, from a single cell to multicellular to slightly higher organized form of life, the era will change. You will observe that as life has started changing, the eras will change. Here we have next era called as Paleozoic era. Paleo means primitive. Zoic means life. So, a primitive form of life. I'll just divide this periods, which is further divided into many periods. It starts at around 500 million years back. Now, before I proceed, you see 500 million years is not such an old time. So, some records are still left. Here we don't have much records, so we also collectively call it as Precambrian era. Before the Cambrian era, divided in further divisions. Paleozoic classified as Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. These are 6 periods for Paleozoic era. How to remember? You'll remember it in some time. See, in this Cambrian era, invertebrates dominated. It dominated. So, if you see this Devonian, if you have heard about devilfish, it is, you can remember it by that, D for devil, D for Devonian. It is called as age of fishes. Now, let us analyze this point and focus on this point. If Devonian is the age of fishes, that means fishes dominated in the aquatic habitat, then invertebrates must have flourished in the Cambrian and Ordovician, and the first fish must have developed in Silurian period. So, Silurian period first fish, Devonian period dominated. And we know that fish is a higher form of life, animal life. So, invertebrates must have evolved to develop fishes. So, this time frame, Cambrian and Ordovician, must have been the time of invertebrates, dominance of invertebrates. Right? And then Silurian becoming the age first fish, and Devonian becoming the age of fishes. Coming to the Carboniferous now. See, Carboniferous period, the word Carboniferous means coal containing. It is, that means rocks which contain coal, which contain carbon. So, carbon containing rocks are basically coal. And we know the formation of coal. It's the carbon extract of plants. So, if it is a carbon extract of plants, that means this time there must have been plants on terrestrial habitat. Otherwise, coal could not have been formed in this time. The dominance of plants in terrestrial habitat, Carboniferous. Carbon containing rocks, they were formed. Okay. Now let's go back to this Devonian time. Devonian is the age of fishes. That means the competition for food must have increased in the aquatic habitat. There must have been fight for having food, more food. So this competition for food and for dissolved oxygen pushed animal life towards terrestrial habitat. And we understand that fish, when it tries to come out of the water, not able to survive, so we need, it must have led to some kind of modifications in life, modifications in body structure, and amphibia. That is organisms which can survive both on land and water. So during this Carboniferous period, there must have been the age of amphibians. Because now the demand for food and oxygen increase in the oceans, so animal life is pushing towards terrestrial habitat. As it cannot adapt these changes suddenly, so there is a transition phase called as amphibian phase. So as life is changing from aquatic to terrestrial habitat, era changes here, and now it is called as Mesozoic era. Called as Mesozoic era. It is further divided in 3 periods: Triassic, Jurassic, Cretaceous. Amphibia comes towards terrestrial habitat. Conditions are drier, adaptations take place. That means now the life has changed and reptiles must have evolved. Because now the sunlight is direct, rate of evaporation is higher, rather transpiration is higher. So some changes and then reptile formation, which further led to the age of dinosaurs. We all understand, we have also been aware of this Jurassic period, Jurassic age through films and all. So Jurassic time, age of dinosaurs, and the terrestrial habitat must have been filled with lots and lots of vegetation. Only then these big animals could survive. This is how Jurassic period must have placed, that age of dinosaurs. Then we see in Cretaceous period, see, one of the reasons for the extinction of reptiles, dinosaurs rather, sorry, I beg your pardon, not reptiles, dinosaurs. One is the American theory which says that there was some extraterrestrial activity which led to the fire everywhere and dinosaurs died. There is another theory given by biologists which say that it could have been also because of ice age, because these bigger animals do not survive in colder climatic conditions. So Cretaceous must have been ice age. Important for us, but usse bhi important hai evolution of birds. So this Jurassic and Cretaceous period, birds must have evolved. And there's a theory given by E. Huxley who says that birds evolved out of reptiles. Because life is more arboreal, airborne, living on trees. There was a fight for survival on the terrestrial habitat. Animal life started shifting towards trees. In the due course of time and evolution took place, birds like wings were developed, feathers developed to provide buoyancy and so on. And to prove this claim that dinosaurs gave birth to the birds, or reptiles gave birth to the bird, we also have Archaeopteryx, a fossil which is also called as a connecting link, a fossil kept in various museums and all. This fossil had beak, like birds have beak, this had beak with teeth in it. Birds do not have teeth. So rest of the features were of reptiles, and there were some features like wings, like beak, that of birds. So they say that there must have been a link between the evolution of birds and reptiles. So from Jurassic to Cretaceous, birds must have evolved. Life again becomes more complicated. It becomes more airborne, change in life. So now we have another era called as Cenozoic era. More advanced. Cenozoic era is divided in tertiary and quaternary period. Then there will be few more periods added to it. Tertiary period. Now you understand that tertiary period is not very old. It is around 180 million years back or so. So we have a lot of records left of this tertiary period. Those records of tertiary period can help us to divide time into a smaller framework. So we are able to divide tertiary period into various epochs, including Paleocene, Oligocene, beg your pardon, Paleocene, Eocene, Oligocene, Miocene, Pliocene. These 5 periods in tertiary period, 5 epochs in tertiary period. You must focus on Miocene, then we can easily make a link of this. I am taking this off, you can move this. Miocene is M for Mio, M for Middle Himalayas. You can remember, Middle Himalayas originated in this time frame. Now try to use the logic. If Middle Himalayas were formed in Miocene, Greater Himalayas must have been formed before that. So somewhere in Oligocene, Greater Himalayas must have been formed. So after Middle Himalayas, Shivaliks, so Pliocene, Shivaliks must have been formed. So Middle Himalayas, Miocene, if it was formed in Miocene time, then Oligocene must have been the age of Greater Himalayas, and after this, Pliocene as of age of Shivaliks. After this, we go to the Quaternary period, but before we go to this region, Eocene must have been the time when Atlantic Ocean actually started expanding. Formation of Andes somewhere in Paleocene and Eocene time. Formation of Andes, and then Himalayas were formed after this. Then in Quaternary, the division is Pleistocene, which is Ice Age, the recent Ice Age around 1 million years back, followed by Holocene. The evolution of man begins in Holocene, and the recent epoch that we are into is Anthropocene. A recent age like Meghalayan age we are talking about to be added around 4,000 million years back, named after the Meghalayan caves, where we find calcite rocks having age of around 4,000 years, that will be added in Anthropocene. See the word anthropo, that means human evolution, not just evolution, cultural evolution of man must have started roughly around 50,000 years back. Recent ages. So now this is a broad framework of geological time scale. How to remember it? Let's go back. So all of you should remember Cambrian. So before Cambrian becomes Precambrian. And there is one thing we all understand. There was no life at the time of origin of Earth. So Azoic, which continued probably for 2,600 million years. And then Archaeozoic. See, maybe some traces of life, some conservates, some biomolecules. Proterozoic life, single cell to invertebrates. But many invertebrates then evolved and gave rise to another life, little more complicated life, we call it as Paleozoic era, and 6 periods. Now how will you remember these 6 periods? Focus. I'll give you a mnemonic for this. It is cos DCP. Cos DCP. This C stands for Cambrian, O stands for Ordovician, S stands for Silurian, Devonian, Carboniferous, P stands for Permian. So cos DCP, you can remember the periods here. And there, Devonian se shuru kare. Devonian is easy to understand. You start with, take the Devonian. Age of fishes. If Devonian is the age of fishes, then first fish must be in Silurian, right? And invertebrates must have been fully developed in this Cambrian and Ordovician time. Done? Go back further. Carboniferous. It is Carboniferous, carbon containing rocks, that is coal. For coal we require plants. That means plants must have been well developed on the terrestrial habitat. That's only reason how coal have been formed, because the carbon extract of plants becomes coal. So that is why we say coal. Then Permian. If Devonian is the age of fishes, the competition for the food and water must have increased. So now a transitionary phase must have developed. Transitionary phase that gave birth to amphibians. That gave birth to amphibians. So age of amphibians, Permian. Life changes from aquatic to terrestrial. Kya? Mesozoic. Not very old, not very primitive. So to remember this, remember if you remember these tridents, remember trijunction. Remember trijunction. Tri stands for Triassic, Ju stands for Jurassic, C stands for Cretaceous. And Jurassic, all of us understand that, all of us know that it's the age of dinosaurs. So if it's the age of dinosaurs, that means reptiles must have originated somewhere in Triassic. And after dinosaurs, one of the reasons for the extinction of dinosaurs is the Ice Age. So Cretaceous was one of the Ice Ages. And life took a different form from here, called as, now the birds evolved. Right. And life becomes airborne. So here you see, we are studying right from here. No life, understandable. Life is very simple. Life becomes a little more complicated. High invertebrates develop. So Paleozoic, primitive life. This was very primitive. This is primitive life. Life changes from aquatic to terrestrial. Mesozoic, neither very primitive nor very advanced. Here life changes from terrestrial to airborne, arboreal. It changes, era changes, Cenozoic, very advanced life. Divided in tertiary, quaternary. Now tertiary period is further divided into these epochs. See, you can remember this. One point, see, I made a spelling mistakes. So despite of writing Pium Plio, I wrote, in spite of writing Poem Plio, I wrote Pium Plio. Paleocene, so remember this. Pium Plio. Paleocene, Eocene, Oligocene, Miocene, and then Pliocene. M for Middle Himalayas. So if Miocene was a part of Middle Himalayas, Oligocene must have been a part of Greater Himalayas must have been formed in Oligocene. Shivaliks must have been formed in Pliocene. And then there was an ice age, life again changed, Rather there was a change in the time frame. Quaternary, we have Pleistocene, Holocene, Anthropocene. So that you have to remember that. And Holocene is the age of man. Human evolution started with Holocene. And then when we refer to Anthropocene, that cultural evolution of man started. So this is how we can remember geological time frame of Earth. So I'll repeat these mnemonics if you can remember earlier again. Once more, Precambrian, then Paleocene, remember cos DCP, Devonian yaad rakhe, fishes, before fishes, invertebrates, after fishes, amphibians, in between Carboniferous is the age of coal and plants, cos DCP remember. Mesozoic, remember trijunction, Triassic, Jurassic, Cretaceous, Jurassic for dinosaurs. So if dinosaurs in Jurassic, that means Triassic must have been the age of reptiles. Cretaceous age of, rather Ice Age. Then advanced life, it becomes arboreal, Cenozoic, tertiary as well as tertiary and quaternary. Tertiary further Paleozoic, that is Paleocene, Eocene, Oligocene, Miocene and then Pliocene. Remember Paleozoic? Myo for middle, M for middle, M for Myo. Oligocene for greater Himalayas, Pliocene for after middle Himalayas, Shivalics were formed. And then you will just have to remember Quaternary, Pleistocene and Holocene. Now that is just an idea given to you that how you should be approaching a concept. And this is how we should be focusing and actually repeating a topic at least 4 to 5 times so that you can remember it for a longer period of time. Otherwise, if you just read it once, you will not remember it for long. What I have seen over the years that students read it once and expect that they'll remember it forever. We are not silicon chips. Our memory is limited. It's not that we can just see it once and remember. If it is so, then things were very simple. Please read 4 to 5 times at one time. That means when you are approaching a topic, just don't read it and leave it. Read it, think over it, repeat it, think over it, read it again. It will be just an investment of 15 or 20 minutes extra, but then that will enter in your long-term memory. Right? So that is about some basic ideas of how do we approach geomorphology. The basic thing that is needed to understand various rock structures and rock phenomena, we'll be referring to these time frames over and again. So please remember it. We'll see you next time with some more basic classes. Thank you.